Hello everyone, I am Sakshi Singh from MCA First Year Division A at Vishwakarma University. Today I'll be discussing Object Oriented Programming or OOP, an essential paradigm in modern software development. We'll explore its concepts including classes and objects and polymorphisms, along with their definitions, benefits, and practical applications. Let's begin. What is object oriented programming? Object oriented programming or OOP is a programming paradigm based on the concept of objects which contain both data and methods. Think of it as a way to model real world entities and relationships directly in software. Definition: OOP defines a structure where objects act as building blocks for creating robust and scalable programs. Purpose: the purpose of OOP is to create systems that are more aligned with how we think about real world problems, objects interacting with one another. Key features: OOP offers modularity, allowing programs to be broken into smaller, manageable units. Reusability, meaning you can use the same code across projects. Scalability, to grow applications efficiently. And maintainability, to make them easier to debug and update. Some of the popular OOP languages are languages like Java, C++, Python, C#, and Ruby, which are widely used for tools for implementing OOP. Core OOP concepts. Now let's dive deeper into the core concepts of OOP, starting with encapsulation and classes. Encapsulation. Encapsulation is the building of data and methods into a single unit called a class. It ensures informing hiding, where internal details of how something works are hidden, exposing only what's necessary to the outside world. This protects data and improves security. For example, in a car classes, the attributes like brand and year are encapsulated along with methods like drive. From the outside, you only interact with these defined methods without worrying about how they are implemented internally. Classes and objects. What is a class? A class is a blueprint of OOP defining the structure and behavior of objects. Think of it like an architectural design for a house. The design outlines all the details, but the actual house built from it are the objects. What is an object? Objects are instances of a class. For example, a blueprint for a house defines the layout, but each physical house is an object created from that blueprint. Similarly, a car class might define attributes like brand and methods like drive, and each car object will have unique values for these attributes. Classes are reusable, modular, and foundational to programming in OOP, making it possible to create an organized and scalable code. Structure definitions. Beyond classes, we also have structures which aggregate data into a single unit. For example, struct time, int hour, int minute, int second. In structures, each member must have a unique name, but two different structures can share the same member's name. This flexibility makes structures useful for organizing data, especially in languages like C or C++. Polymorphism. Another critical concept in OOP is polymorphism, meaning many forms. It allows objects to behave differently based on their type, bringing flexibility and power to code. Definition: polymorphism enables a single interface to perform multiple functions. For example, the same function name can behave differently depending on the object it acts on. Types of polymorphism. Compile time polymorphism. Method overloading. The same method name is used with different parameters. Example, in a calculator class, an add method might accept either integers or floating point numbers. Runtime polymorphism. A subclass provides its own implementation of a method defined in a parent class. Example, a shape class might have a draw method. The circle and rectangle subclasses can override draw to display their unique shapes. Practical example in Java. Here, the method draw behaves differently based on the object's type at runtime, showcasing polymorphism in action. Accessing members in base and derived classes. In OOP, derived classes inherit the behavior of base classes but can also define their own methods. For example, class B and class D. This hierarchical structure allows for code reuse while enabling customization through overriding. Conclusion: classes and objects. To wrap up, classes and objects are the foundation of object-oriented programming. Classes act as blueprints defining the attributes and methods, while objects are the real-world instances created from these blueprints. These concepts promote organization, reusability, and modularity, making software more efficient and easier to maintain. Conclusion: polymorphism. Lastly, polymorphism adds flexibility by enabling methods to adapt based on the object type. Through method overloading and overriding, polymorphism ensures code can handle different scenarios seamlessly. It supports the idea of write once, use many times, making software scalable, adaptable, and future proof. Thank you for listening.